So this is lesson number 92 in Algebra 2, and the name of this section is Boat in the River Problems. Now, probably none of you will ever have to deal with your boat in the river and there being a problem. So this is more logic, and that's a lot of what math is teaching you logic, and you will need this for things like the SAT and the ACT and college entrance exams, things like that. But really, it's not something you're ever going to use. Surprise, surprise. But it is good to kind of get an idea of what's going here. All right, so first of all, let's do a little bit of discussion on what's going on. So we've got this river, and you've got this boat, and let's say that the river is flowing this way, and you've got this boat here, and it's in the river. Therefore, boat in the river problems. Let's make it a sailboat. All right, so let's say that the river is moving at 3 miles per hour. That's the river current. And the boat is just sitting in the river, and as it goes down the river, it's going 3 miles an hour too. That's because that's how fast the current is going. But let's say that you have a handy-dandy little motor on your boat, making it, whoops, what happened there? Kind of made that kind of big, didn't it? Alright, so there's our motor with our little propeller there. Alright, so let's say that that boat with the propeller on it is going to go, if the water was still, the boat would be going 11 miles an hour. But since it's going downriver, it's going 11 miles an hour with the engine, plus the current is pushing it at 3 miles an hour, so that means the boat is moving at 14 miles an hour down the river. So the boat is helping it with the motor, but the current is also being there to help it go another 3 miles an hour. So we're going 14 miles an hour. Now if that boat turned around and went the other way, and it was going, the motor was pushing it at 11 miles per hour. The current is against it at 3 miles per hour. So the current is pushing the opposite way. So now going up current, the boat is only going 8 miles per hour because we have to take away the 3 mile an hour current because it's pushing the opposite direction. So that's what's happened in the boat in the river problems. When the boat is going downstream, we add the speed of the current. When the boat is going upstream, we subtract the speed of the current. Okay. Now, if you remember from other story problems, the distance an object goes is equal to the speed times the time. So remember that, because we're going to be using these, because we're dealing with speed, and we're dealing with time, and we're dealing with distance. So remember the D equals RT. Alright, so let's look at some of these. So first of all, if we're looking at going downstream, this is what the equation will look like if we use the distance equals rate times time. Okay? So downstream, we'll call it the distance downstream, D sub D. And that will equal the rate, which will be the speed of the boat plus the current of the water. Okay, that's going to be my rate. The boat plus the water times how long you were going downstream. Upstream, and this just goes along with what I had mentioned earlier. Ooh, isn't that a pretty cool little S there? Okay, is also distance equals RT. So the distance upstream is going to be the speed of the boat minus the speed of the water. Remember what I said? The speed is going to be subtracted when you're going upstream, times the distance, or times the time that it takes to go upstream. Okay, so those are our two equations that we're going to look at. Alright, so let's actually look at an example. I'm going to erase this, but you have it in your notes right in front of you, so you can refer back to it. Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? Alright, so let's look at the downstream equation that you have in front of you because you wrote it down, right? and it's going to be the boat plus the speed of the water times the time to go downstream, and that's going to equal the distance downstream. Our upstream is going to be the same, only it's the boat minus the speed of the water times the time upstream equals the distance upstream. Alright, so I just copied down those equations that I erased there. Alright, so let's see what we've got here. The times are equal because it said it took the same amount of time, so the times are equal. And what else do we know? The rate of the boat was 8, and the distance downstream was 60, and the distance upstream was 20. So this equation, we'll start filling in our blanks. We have 8 plus the water, because the boat was going 8 downstream, or in quiet water, 8 plus the speed of the river. The time is going to be the same, so we can just use a t. We don't have to worry about a td or a tu because they're both the same, so we'll just use a t there. And that equals downstream, we want 60 miles. Now let's go upstream. Upstream was the speed of the boat minus the speed of the water times our time, and that equals 20 because we could only go 20 miles upstream. Alright, so let's go ahead and distribute 8t plus tw equals 60, and do the same over here. 8t minus tw equals 20. Okay, so there's our two equations there. So let's use elimination to solve these two because they're right there. We're going to use 8t plus tw. Oops, that's not a lowercase w, is it? It's a speed of the water. Equals 60. And then we'll take the 8t minus tw equals 20. So what we're doing is we're putting these two together, and we're eliminating both the t and the w here and here. That's our goal here, so that we only have one variable at t. So when we add these are going to go away. So we have 16t equals 80. And when we do the math, we get t equals 5. So 5 hours on the river. Going downstream, we went 60 miles in 5 hours. Upstream, we went 20 miles in 5 hours. And what are they asking for? What was the speed of the current and what were their times? Okay, so we found the times. The times were 5 hours. Alright, what we're looking for is the speed of the current. Speed of the current. So we're looking for W right there. Okay? So all we have to do is put 5 in for T and solve for W. So let's do that. So we've got 8 plus W times 5 equals 60. I'm just going to do it over here in this little space. 40 plus 5W equals 60. And subtract 40 from both sides. Divide by 5, divide by 5, and our W equals 4. So our speed of the current was 4, and that's what I'm looking for. So that's it for example 92.1. Okay, so you kind of see the method, the way that we do this. Well, let's try 92.2. Okay, so there's our formula. This is our downstream, and this is our up. Before we even look at this one, the steamboat Juby Fountain could go 70 miles downstream in 5 hours, but required 6 hours to go 48 miles upstream. So notice the times are not the same. Downstream was 5, upstream was 6. What was the speed of the boat in still water, and what was the speed of the current? So I'm looking for the speed of the boat, the B, and I'm also looking for the speed of the water, which is W. So I'm looking for both of these. Alright, so let's see what I've got here. Let's replace some of the letters with what I've got. I have no idea what B and W are, so I'm just going to leave it as B plus W times, going downstream was 5, and we went 70 miles. Upstream, again, we don't know what B and W are, but we know the time was 6, and we went 48 miles. Okay? So given that information, let's go ahead and distribute. There, and over here. Okay, nothing creepy yet. Alright, so now what we're going to do is we're going to put those two problems together, stack them, and use a system of equations. Oops, why do I have a 7 there? That was kind of weird. 6b minus 6w equals 48. Okay, so we have a system of equations. So we can get rid of the b or the w. It doesn't really matter. And then we can solve from there. So let's multiply the top by 6 and the bottom by 5, and that will give us our 30s. So we have 30, this is the top one, .48 times 5, 240. Add those, and those go away. So I have 60, B equals 660. So B equals 11. Okay, so I found how fast the boat's going. Now I need to find out how fast the water was going. So I just go ahead and grab any of these equations, doesn't really matter which one, and put 11 in. So I'm probably going to pick one of these two. I mean, I could pick this one, but then I'd have to distribute, and this is already distributed. So in blue here, I've got 5 times 11 plus 5w equals 70. So 55 plus 5w equals 70. So 5w, 70 minus 55 is 15. So w equals 3. So that's the speed of the water. So I found both my answers there, just doing the same thing. Writing two equations, one downstream, one upstream, and then distributing, and then stacking and doing elimination, finding one of the answers, plugging it back in, finding the other answers, and you're done. Same method on every one. So let's do one more and then we'll be done. And that'll show up in the next video.